G.K.Jain schools, a great way to start your child's early education.
Subscribe now and press the bell icon. Never miss an update.
Good evening children, this is Padma from G.K.Jain schools. Let us continue with Integral Calculus 2 from 12th Business Maths. In today's topic we are going to see about the area of the region bounded by the curves. There is nothing but the geometrical interpretation of definite integral. Also area between the curves, its different types, the example sums related with those topics, and also the exercise 3.1. Let us move on to the topic now. So this is Integral Calculus 2. We are on the third chapter children. So the first type is, if the area of the region bounded by the curve y equal to f of x with x-axis and the ordinates are x equal to a and x equal to b, means the area is given by integral a to b y dx, that is a to b f of x dx. Okay, so this is when you have the x-axis to be bounded by the curves. Then we have something, area of the region bounded by the curve y equal to f of x between the limits x equal to a, x equal to b, and lies below the x-axis, which is integral a to b minus y dx or minus integral a to b f of x dx, because it is lying below the x-axis. Okay, and we have something called area of the region bounded by the curve x equal to f of y, where between the limits y equal to c and y equal to d with y-axis and area lies to the right of the y-axis. So that is a is equal to integral c to d x dy, which is equal to c to d f of y dy. Okay, because it is lying to the right of the y-axis. And similarly, area bounded by the curve x equal to f of y between the limits y equal to c and y equal to d with y-axis, where the area is lying between the left of the y-axis. That is why we call a is equal to integral c to d minus x dy, which is equal to minus integral c to d f of y dy. These are the various types involved in the area. And we have something called area between two curves. When you are having two curves, the area between the two curves is given by a is equal to integral a to b f of x minus g of x into ds. You can see it from the figure also. There are two curves and we are finding the area in between them. Let us move on with the example sums children. Example 3.5. The previous examples are very easy. Let us start with example 3.5. Find the area of the parabola y square is equal to 8x bounded by its latest rectum. So the parabola equation is given to be y square is equal to 8x. So first name that y square is equal to 8x, and we can draw the rough figure of the parabola y square is equal to 8x. So you have you have seen about this parabola and its types of parabolas in your 11th standard. We have four types lying in four different quadrants. Y square is equal to 4ax, y square is equal to minus 4ax, x square is equal to 4ay, and x square is equal to minus 4ay. So comparing with the general form y square is equal to 4ax, in the place of 4a I am having 8. So 4a is equal to 8, which means a is equal to 2. Which means my focus will be a comma 0, right? The parabola is opened rightward, so the foci will be a comma 0. So a is 2, so 2 comma 0. So the lattice rectum will be, if this is going to be 0 and this is going to be 2, means obviously it is 0 to 2. So equation of lattice rectum is given by x is equal to a, means x is equal to 2. So it is symmetrical about the x-axis. So you have two parts here, okay, lying on the first quadrant and lying on the fourth quadrant also. So obviously required area will be area in the first quadrant between the limits x equal to 0 and x equal to 2. So a is equal to twice, since the curve is symmetrical, since the parabola is symmetrical about x-axis, twice into integral 0 to 2 y dx. Why we are having it to be 0 to 2? Because that is the measurement it is having. Okay, that is where the parabola foci is identified now. So integral, I can take the 2 outside, because 2 is already outside only. Since it is symmetrical, we are taking it to be 2, and y square is equal to 8x means y is equal to root of 8x. What is root of 8? 4 into 2. So 4 means you can take it as 2. So 2 root x root 2. So I will write it as it is, and once again I can take this 2 root 2 outside. So what happens now? So 4 root 2 integral 0 to 2 x power 1 by 2. So root x is nothing but x power 1 by 2. So the formula is x power n, formula is x power n plus 1 by by n plus 1. So x power 3 by 2 by 3 by 2, and this 3 by 2 denominator can be taken as 2 by 3. Now what will happen? 4 2s are 8, 8 root 2 by 3, and this will be upper limit minus lower limit. Upper limit is 2 power 3 by 2 minus lower limit is 0 power 3 by 2. What is 2 power 3 by 2? Shall I write this 2 power 3 by 2 as 2 power 1 by 2 the whole cube? And what is 2 power 1 by 2? Root 2. So root 2 into root 2 into root 2, already I am having a root 2. So root 2 into root 2 is 2, root 2 into root 2 is 2, 2 into 2 is 4. So obviously I am having it to be 4 8s are 32, 32 by 3 square units. And example 3.6, sketch the graph y is equal to modulus of x plus 3. So this is very important 3 mark sum, and evaluate integral minus 6 to 0 modulus of x plus 3 dx. First you have to define the function. Since it was given with the modulus, which means it have a positive and negative value. So x plus 3, if x is greater than or equal to, that is greater than or equal to, when it goes to the greater side it will be having positive value. When it getting into the lower side, that is when the value is getting decreased, it will have the negative value, minus. So required area is equal to integral b to a y dx. Okay, so y is equal to, see, y is equal to x plus 3. Suppose when I am going to put y is equal to 0, what will happen? X plus 3 is equal to 0, x takes the value minus 3. That is why we are going to apply the limit to be minus 6 to 0. We have given the limit to be minus 6 to 0, but minus 6 to 0 means minus 6, and after that there will be minus 3, and then only we will be having 0, right? Minus 6, minus 3, 0, and then we will be having the x-axis over there. So we have two types, that is x plus 3 also there, x minus 3, minus of x plus 3 also there, since it was given in the modulus. So we will split the limits as minus 6 to 0. Okay, we will split this minus 6 to 0 as minus 6 to 3, minus 3, and minus 3 to 0. So minus 6 to minus 3 y dx plus minus 3 to 0 y dx. Now minus 6 to minus 3 means it is getting to the lower part. Lower part means what is the definition? Minus of x plus 3. And if it is greater than minus 3 means minus 3 to 0 means it is x plus 3. So substitute, no? X plus 3 minus x plus 3, take the minus outside, x plus 3. So x plus 3, it is considered to be 1. So x power n means x power n plus 1 by n plus 1. So 1 plus 1 by 1 plus 1, here also 1 plus 1 by 1 plus 1. Then applying the upper limit and lower limit. Upper limit is 0. Here for upper limit, here for this function it is minus 3 and minus 6. For this it is 0 and minus 3. So applying the upper limit I am getting it to be minus 9. Here the lower limit is minus 6. So when I am going to apply minus 6 plus 3, it is going to be minus 3. Okay, so here only I will be getting the value as 9, and here minus 3 plus 3 will become 0. Similarly here also it will become 0. Here only I will get it to be 9. So I am getting it to be half of 9 plus 9, which is 18 by 2. So 9. So the area is 9 square units. So this is how we have to do this sum. This is very important 3 mark sum. And we have, using integration, find the area of the circle whose center is given to be A. Okay, so now this is the circle. Okay, it is starting from 0, whatever may be the circle, no, it will have a origin, center O, and the radius is given to be A. So this is also a radius, this is also radius, this is also radius, this is also radius. All these are radius only, and this will be considered as a diameter, this is also diameter. So the equation of the circle is x square plus y square is equal to a square. Putting y is equal to 0, I will get x square is equal to a square, means x is equal to plus or minus a. So the curve is symmetrical about all the 4 quadrants, actually both the axes. So we'll have the required area to be 4 into the area between 0 and a, and also x square plus y square is equal to a square, means y square is equal to a square minus x square, and y is equal to root of a square minus x square. So 4 into fourth of, that is 4 times the area we have to find out, 4 times, because one particular quadrant only we are going to find out, which is lying between 0 to a. So all these quadrants will be considered as 4 times of 0 to a y dx, that is this one. And for this one we have the direct formula, x by 2 root of a square minus x square plus a square by 2 sin inverse of x by a. So I am just substituting the formula, and I am going to apply the upper limit minus lower limit. First upper limit I am applying, upper limit is a, wherever x is there I have substituted a, and lower limit is 0. So a minus a, this becomes 0, a by a it is 1. And what is sine inverse of 1? Sine inverse of 1 is sine 90 degree, right? 90 degree only sine gets 1. So it is pi by 2. So we are substituting it to be pi by 2 and sine 0 becomes 0. So we are getting it to be a is equal to 4 into 0 plus a square by 2 into pi by 2 and minus this becomes 0. So obviously it is 4 and 4 gets cancelled, pi a square. What is the area of a circle, children? It is pi r square, where r is the radius, and here it is pi a square because a is the radius. Okay, now example 3.8, using integration find the area of the region bounded by the line x equal to 4 and the parabola y square is equal to 16. So we have one line and parabola. Parabola is y square is equal to 16x. So y square is equal to 16x means it represents a parabola which is open rightward. And 4a, when I compare it with the general parabola, a gets the value 4. So obviously it is symmetrical about x-axis. So I will find the area twice. Okay, it is symmetrical about x-axis. So twice into, and y square is equal to 16x means y is equal to root of 16x. That is y is equal to 4 root x. Now I will substitute the value twice integral 0 to 4 root x. I can take the 4 also outside, and x is nothing but x power 1 by 2. If I take the integration, no, it will be x power 3 by 2 by 3 by 2. I can take this 3 by 2 to the outside. So 8 2s are 16 by 3, and upper limit minus lower limit. Upper limit is 4 power 3 by 2 minus 0 power 3 by 2. So what happens here? It is root 4. Root 4 is nothing but what? Root 4 is 2. So 2 cube is 8. So the answer is 128 by 3 square units. So this is how you have to do this, children. Children, in today's class, we have seen about the area of the region bounded by the curves in terms of the definite integral. We have seen all the example sums. In next class, we will be seeing about the exercise 3.1. Thank you, children.